This is the first question. Consider the time series yt is equal to 0.7 plus 0.4 yt minus 1 plus 0.12 yt minus 2 plus ct. This is the first exam question. Yt is equal to 0.7 plus 0.4 yt minus 1 plus 0.12 yt minus 2 plus ct. Identify the model as an ARIMA PDQ process. This is part 1. Part 2 is determine whether yt is stationary or not. Then you have to calculate E of yt. Okay. Now when you studied something, how you will be able to relate to this one when it comes to an exam question in time series. In different chapters you see you have to connect differently. Coming to time series, I have shown you the first question. It's not a Markov process because there is dependency more than one. If you want to predict for t, if t is 2022, you are depending on 2021 figure and 2020 figure. If you see the question immediately, you see how many years past dependency you have. So if you are predicting something at t, okay, if you want to predict something at t, how many past dependency you have, you want to know something at t. There will be innovation at t, that's fine, the random shock. Otherwise the value at t will depend on two values, two past values. Here t minus 1, t minus 2. So you have two term past term dependency. So you can think that there are two types of AR. Okay, that's fine. Now we'll check for MA. How many MA are here? If you check here, there is only one random shock at time t. We don't have any error for this one, any error for this one. That means MA terms are absent here. We are not using any error term here. Okay, ET will be there always. In all kind of ARIMA processes you will have ET. But we don't have ET minus 1, ET minus 2, ET minus 3. So MA part is not there. That's fine. What is mu here? From this question, what is mu? Can you say what is mu here? Average of the process. If you want to write this way, you have to write alpha 1 yt minus 1 minus mu alpha 2. See, either there will be nothing here, no 0.7, 0 will be here, or there will be something that might not be mu. That is what I am saying. Yt minus 2 minus mu. If you want to write this way, make it sure that this and this, they are the same. So if you have 0 here, yt minus 1 minus 0, then that 0 is not equal to 0.7. So mu is not 0.7 from this process. Mu is not 0.7. And if I remember, I already explained in one problem how to find mu. Okay. So if you collect all the coefficients, all the constant terms, mu, you will get minus alpha 1 mu minus alpha 2 mu. If you write this way, then I can write alpha 1 yt minus 1, here alpha 2 yt minus 2 minus alpha 2 yt minus 2 and plus et. So if you check this one, alpha 1 yt minus 1, alpha 2 yt minus 2, okay, and these two I have taken here. This should be equal to 0.7. Okay, so mu minus alpha 1 is 0.4 here, mu is again 0.7 minus alpha 2 is 0.12, mu once again I could have taken common, but it's okay. Alpha 1 mu minus alpha 1 is 0.7, then let me write here sorry, let me write this way. mu I'll take common, 1 minus alpha 1 minus alpha 2, this total is given 0.7. Okay, so that is 0.7. Now what is mu 1 minus alpha 1? Alpha 1 is 0.4, alpha 2 is 0.12. Okay, this is 16. Sorry, this is not 16, this is more 40, 52. So mu will be equal to 0.7 divided by 0.52. Okay, 7 divided by 52 if I am not wrong, because this is 40, 12, 52 means 48. You will get 48. Is it okay? 44 means 40, right? 40 plus 12, 52, 1 minus 52, 48. 0.48 will go here. Let me write 0.48. Do you agree, Anu? 0.48.
Yes, sir.
So 7 divided by 48. Okay, 7 divided by 48. So mu will be 7 divided by 48. Mu is not 0.7. So either this will not be given. If this is given, then make it sure that you will get this way. Okay. If I change this question, I write 0.4 here minus 0.7 this way, and here 0.12 minus 0.7, then 0.7 will be mu. So that is something you need to remember. In any case,
Okay, sir.
yeah. In any case, what will happen is you can transfer, because once you know mu, okay, when you find characteristics polynomial, this will have no use, let me tell you. But if you are finding mu, you have to do this way. There is no other alternative. Okay, maybe they asked here to find mu, we'll do in a different way, okay, in part 3. But seeing the question, you have to know that this has no use. Okay, now if you want to write yt, this is the normal way you are supposed to write. 7 divided by 48 plus 0.4 yt minus 1 minus 7 divided by 48. Now you can verify they are the same. Okay, 0.12 yt minus 2 minus 7 divided by 48 plus et. You will get this way. Okay, you will get this way. In any case, what you need to remember is you have a time series where you can always transform to the form which is easier. So what I need to do is I need to change to xt. Yt minus 7 by 48 will be my xt. So my new equation will be this one, xt, that is equal to 0.4 xt minus 1, okay, plus 0.12 xt minus 2 plus ct. I can turn to this way. So while changing to this form, remember, you don't need this 0.7, but mu is not 0.7. That is what you need to remember. You can ignore this term for the time being, and you can see how can you find et by part 3 will do here. Okay, but remember, you can consider this one while finding characteristics equation. While finding characteristics equation, this will have no meaning. But remember, this is not mu here. That is what I am saying. You will get in 3 forms exam question. You will not get here something 0, and you will get something you should not consider, that is mu. If you get in the original form, general form, okay, this should reflect here also. These are the 3 ways. Now let's find characteristics polynomial. If I write characteristics polynomial, then it will be 1 minus 0.4 z, okay, minus 0.12 z square. That should be equal to 0. You have to solve this equation. Or what you can do is, before saying that this is AR2, there is no D term. That means D0, Q0. Q0 you can see, and you can say from the equation. 2 you can say by counting the number of path dependency in terms of the original time series. But you have to make it sure that there is no D. No D means no unit root. If you have a unit root, then there is a problem. So put 1 here, check that left hand side is not equal to 0. Okay. So put 1 here, 1 minus 0 0.4 minus 0 0.12. This is not 0. If you put Z1, okay, left hand side is not 0. That means 0 is not a root. Because 0 is not a root, there is no D here. D is 0. So how you find D normally? The 0 root. Suppose I get like this. Sorry, I have to put Z1 here. Okay. So if you put Z here, I am not getting 0 left hand side. Right. This is 40, 50 to 48 I am getting. 0.48 is not equal to 0. So 1 is not a root. Not a root of the equation. Okay. So if 1 is not a root, then D will always be equal to 0. That is what you need to check. If 1 is a root, that means 1 minus Z will be a factor here. If you get any 1 minus Z factor, okay, then you will have D also. So you have to check for that, whether you have 1 minus Z factor or not. Even that is not required. If you have a cubic polynomial, it will take a lot of time. Okay, you just put Z1 or not. If you put Z1, it becomes 0, then there is at least 1D. Okay, then you have to apply differencing. Then again you put Z1, this becomes 0 or not, left hand side. If that is there, D will be 2. That way you have to proceed. But in this question, fortunately, there is no D. So yes, your answer is correct, AR2. But not randomly, you have to check it. Now when you go to part 2 here, stationary process, anyway you need to solve this one. Okay, so when you come to part 2, anyway you need to solve this. So if you solve this, you will get this way, 12Z square, okay, plus 4Z here minus 100 is equal to 0. This is 40. I have to multiply by 100, okay, minus 100. So this will be 40, that will be equal to 0, okay. So if I get 40 here, 12 multiplied by 100. So then I can take 4 common, 3Z square plus 10Z, okay. So 4 minus 25 is equal to 0. So 25 multiplied by 3, 5 into 3, 15, okay. So I can write this way, plus 15Z minus 5Z minus 25 is equal to 0. Then what will happen? 3Z, Z plus 5 minus 5 minus 5 Z plus 3 is equal to 0. Okay, this is a quadratic equation. Anyway, you will be able to get the answer. So this is 5 by 3 greater than 1, and the other one is minus 3. This is also greater than 1 in absolute value. Okay, so Z mod greater than 1 here and here. So alpha you can say 5 divided by 3, or Z1, Z2 you can say Z1, because alpha beta we use differently. Greater than 1, Z2 mod greater than 1, okay, minus 3. In absolute value, the roots are greater than 1. So this is stationary. If you do part 2, you will be able to know that there is no root which is equal to 1 anyway. Anyway, after part 2, you will be able to say that it's AR2. But before doing part 2, how can you know it's AR2 or not? You may not get a question part 2 directly if you are supposed to answer whether it's ARIMA or not. You have to check for unit roots. Remember, that is part 1. But after doing part 2, you are sure that there is no root 1. Okay. And it's stationary. It's not only AR2. AR2 is stationary. Remember, not all AR2 processes are stationary. Not all AR1 processes are stationary. This is something very important. That's why I am repeating, so that you will remember every time. ARP process is not always stationary, and we'll see how can you know whether a process is stationary or not, whether a process is AR2 or AR1. Maybe after 1 or 2 classes we'll see all those. I will show you through our coding, the beautiful realizations you will be able to see and you will be able to understand. Okay, if you get a data, you will be able to apply some model. Just remember, not all ARP processes are stationary. You have to check for the roots. If the roots are greater than 1 in absolute value, this is a stationary process. Then in part 3 you have to calculate EYT. Remember, I said how to know mu in part 1. Now in part 3 you can know mu. There is a easy process, but how? See, in part 1 also we found mu, but in part 3 now we'll find mu. This is not true each time. If the process is stationary, if part 2 is satisfied, then only you can do this way. Okay, so from part 2 only you can come to part 3. Okay, if you want to mu in part 1, you have to follow whatever way I found 7 divided by 48, that way. Part 3 you can apply whatever way I will do now, that you can do only after part 2, because knowing that this is stationary, remember EYT is constant in stationary process, so what will happen is EYT will remain constant. That we proved in part 2. So from part 2 only you can go to part 3. Okay, this will be 0.12 EYT minus 2 plus expected value is 0. I have taken expectation both the sides. Okay, so mu I got here. Let me write here, mu is equal to 0.7 plus 0.4. Again this will be mu. This they are equal because this is stationary. All are equal. So if you take mu here, you will get 0.12 mu, and you need to solve this one. Okay, so 1 minus 0.4 minus 0.12 mu, that will be equal to 0.7. Then mu will be equal to 7 divided by 48. 7 divided by 48. Calculate the autocorrelations rho 1, rho 2, rho 3, rho 4. This is the question. Autocorrelations. How can you calculate autocorrelation for AR process? If you want to do that, autocorrelation here, AR2 process, here you need to write Yule-Walker equations. Okay, you need to write Yule-Walker equations. So you have to find autocorrelations. How many autocorrelations you are finding, that also you have to know. Rho 1, rho 2, rho 3, rho 4. Okay, so we don't need to solve any equation. Directly you can find through Yule-Walker equations. Okay, through Yule-Walker equations you will be able to find all these autocorrelations. So I would like to write Yule-Walker equations. Okay, remember Yule-Walker equations we use only in AR, not in MA process. Finding rho 0, rho 1, rho 2, rho 3 in MA process is totally different if you compare with AR process. And also let me tell you that we have not solved a problem where you have both AR and MA, though it will be like Yule-Walker, but it's not complete like that. I'll go to that later. But remember, this is AR process, so you can apply Yule-Walker equations. Okay, remember you have to write all the equations. You have to find the covariance between yt minus 1, yt minus 2. That will take a long time, so directly you can use Yule-Walker equations. Okay, so if I write yt minus 1 here, I will get gamma 1. Okay, gamma 1 here I'm finding with yt minus 1. So forget about 0.7 now, it will have no use, or maybe if you want you can write in that way. So you consider this coefficient, okay, this one and this one, or maybe if you have any confusion, you transfer this to this form. Already I did that. You write in terms of xt, because in xt mu will not come anyway. This will be 0.4 xt minus 1 plus 0.12 xt minus 2 plus ct. So in this series transform 1, there is no 0.7, no confusion, okay, where xt I can write yt minus 7 divided by 48. So this is my new one, okay. Here I have to find the, I have to write the Euler-Walker equations. Do you remember Euler-Walker equations, how to write? If you start with 1 here, I can continue writing, remember. So from 1, the next one is, I mean, you have to go down here. From 1, you will have to go to 0. So you write the coefficients, because 1, how you get, that means you are finding covariance between left hand side xt to xt minus 1. Then you will get gamma 1, right? So if you find covariance with xt minus 1 here for this term, it will be gamma naught. So remember, you need to write the coefficients, whatever coefficients are given, 0.4, 0.12. Let me write everywhere 0.4, 0.12, 0.4, 0.12, 0.4, 0.12, 0.4, 0.1. So now here 1 I have written. So if you apply Euler-Walker equation, you have to write 0, and then you have to go deep down. There is no nothing, 0 is final. So you will get minus 1 here, because you are not restricted to only 0. You can go to negative side as well. But minus 1 is equal to 1. Will not mind writing 1 in place of minus 1, because covariances, when you write covariance xy will be equal to covariance yx, okay. So now when you write 2 here, you will get 1, then 0, and when you write 3 here, you will get, the next one is 2, then 1, okay. If you write 0 here, you will get minus 1, that is 1, minus 2, that is 2, and extra sigma square you need to write, remember. And invariably in all problems this will be given, okay. It is a zero white noise process. Always you need to check that. It's a white noise process with variance sigma square. So although 0 is not given, it's always 0. So ET will follow normal 0. This is always there, 0 sigma square, okay, even if not given. So this is sigma square, okay. We have to write sigma square here. That you will get in gamma 0. These are the Euler-Walker equations when you get AR processes, pure AR processes, okay. Now you need to solve all these. You know how to solve. So you divide gamma naught to the first equation, you will get gamma 1 by gamma naught, that is rho 1, that will be equal to 0.4 plus 0.12 rho 1 here. This will be our first equation. You can solve and find rho 1 from here. Divide by gamma naught here to the second equation, you will get rho 2. Rho 2 will be equal to 0.4 gamma 1 by gamma 1, gamma naught, that will be rho 1 plus 0.12. This is 2, okay. So if you solve first equation, you will get rho 1. If you solve second equation by putting rho 1 here, you will get rho 2, okay. Now rho 3 will be equal to 0.4. Here you will get rho 2, you know already rho 2 now, plus 0.12. So this is rho 1, okay. So you know already row 1, row 2, you will get row 3, that's all. If you want to find row 4, you can write similar. You need not go here. We are not using this one. Remember, till now we are not using this one. This requires another one. So row 4 if you find, you can just write all this. You leave this one separately. Okay. This is the only term where you will get sigma square. So row 4 if you write, you can follow the pattern. 0.4, row 1 I have written here, I will write row 2. Then 0.12, row 2 I have written, I will write row 3. Row 2, row 3 you got already here. You will get row 4. If you want row 5, you find row 5 here. Express row 5 in terms of row 3 and row 4. You put here, you will get this way. So in the exam questions, if you want to find up to 3, 4 or 5 or even 6, you can use this way. But if they will ask you to find row 500, you can do it 500 times in 3 hours. For that, you have to solve it and you have to express row t. Okay? Row t in terms of only t. So that you can directly put get here. These are the recursion equations. Okay? These are the recursions. That means they will not give you direct solution. If I want to write row t here, it will be 0.4 row t minus 1 plus 0.12 row t minus 2. If you try to find from here, if you write 500, you will get 0.4 row 499 plus 0.12 row 498. So you are not getting the solution from a recurrence type relation. You need to solve it. If you solve it, you will be able to express row t in terms of t, where you can directly put the value and get the answer. That's why you have to solve this one. But in this question, no such method is required. Okay, let's move to question 2. This is the time series model where it is a white noise process with variance sigma square. Determine the values of alpha for which the process is stationary. So the question is, determine the value of alpha for which the process is stationary. That means you have to solve this, right? So let me write the characteristics equation. I'll write 1 minus 2 alpha plus alpha square. 1 minus 2 alpha z I have to write. Okay. Plus alpha square z square is equal to 0. I need to solve this one. So alpha square z square, it looks like 1 minus alpha square, right? 1 minus alpha z square 0, that means alpha z 0, z is alpha. If you say you have only one root, this is wrong. Okay, you don't have only one root, you have two roots here because square is there. Both 2 times you have to make it 0. So 2 roots are here, 1 by alpha. So 1 by alpha should be greater than 1. That means alpha must be less than 1. So you take any alpha less than 1. Okay, so if you take alpha less than 1, suppose half or something like that, 1 by 3, whatever, then this will be stationary. Okay, so determine the values of alpha. What are the values of alpha? When you say alpha more less than 1, any number between minus 1 to 1 you have to write. Okay, any number you take between these two, mod will be less than 1. So 1 by alpha mod will be greater than 1. Then this will be stationary. So this is not stationary always. This will be stationary only when these all are greater than 1 in absolute value. Even if this is equal to 1, there is a problem. They should be greater than 1, strictly greater than 1. Okay, the absolute values should be greater than 1 strictly. If equal to 1, then also there is a problem. That means suppose I will take 1 by alpha exactly equal to 1. That means alpha 1. Let me put alpha 1 here. Then what will happen? Because we talked about alpha 1 by alpha greater than 1, it's stationary. Less than 1, it's not stationary. Okay, now take 1 by alpha exactly equal to 1. Let me write this one. yt minus 1, I have yt minus 1, okay, then minus yt minus 2 plus ct. If you get this equation, you can term this as AR. This is 1 minus alpha b power 3 xt is equal to et. See, remember, if alpha is equal to 1, there is a problem here. Okay, if alpha is equal to 1, you will get this will be an integrated process because 3 roots you see. Normally it will be 1 minus alpha z power 3. Okay, that will be the left hand side equation, characteristics polynomial. So 3 roots you will get 1. So it will be I3 process. It will be a I3 process. Okay, so alpha should not be equal to 1. That's for sure. Now if alpha is 0.4, then if you put alpha 0.4 here, your characteristics polynomial will be, anyway there is no MA part, I am not discussing about that. It will be 1 minus alpha, and you write z here, power 3, 0. So z will be 1 upon alpha 3 times. Okay, 3 roots all are equal. So alpha is 0.4, that is 4 by 10. Okay, so this will be 10 by 4, 5 by 2, 5 by 2 3 times. All are greater than 1 in magnitude. Just apply that. So this is a stationary process when alpha is 0.4. So this is AR3. This is AR3. No MA part, no ET minus 1 term, and no unit root. So this is a pure AR3. But in AR3 all roots are equal. Never mind. All are equal. Okay. And alpha is 0.4. Write the Euler-Walker equations. You can do that always. Calculate the first two values of the autocorrelation function rho 1 and rho 2. Cool, right? Only 2 you need to find. So apply a similar procedure. The Euler-Walker equation you can solve and you can find. Now this is the next question. Question 5. The following time series model is used for the monthly inflation rate YT in a particular country. YT is given. ZT here is ET. Okay. Sometimes they use ZT as well. You need not worry, and they explained also what is ZT here. So YT is equal to 0.YT minus 1, 0.YT minus 2. Okay. Don't worry about this. I think this question is similar to question 1 once again. This is not mu. Okay. But we have to check if there is a unit root or not. 0.4 z minus 0.2 z square. Okay, this is the characteristics polynomial. If you put 1 here, left hand side is not 0. So there is no MA part. So you can safely write AR2 once again. No MA part. It's not an integrated process. There is no unit root. Okay, this is AR2. This is the AR2 process. And then you can continue D0, Q0 and determine whether this is a stationary process or not. Find the roots of characteristics polynomial. All those you can do. Okay. The next question. The time series is assumed to be stationary and to follow an ARMA 2-1 process. ARMA 2-1 means C, xt minus 1, xt minus 2. 1 means there is a et minus 1. Okay, here is z. These are independent normal. Sigma is also given 1 here. So this is given. This is ARMA 2-1 process defined by this. This is not ARIMA. You need not check for a unit root because we are not talking about ARIMA. Whenever you see ARIMA, then only you check about unit roots. Now what you need to do here, determine the roots of the characteristics polynomial, explain how their values relate to the stationarity of the process. All those you can do. Find the autocorrelation function for lags 0, 1, 2. Derive the autocorrelation at lag k in the form this. Okay, the same thing. Okay, rho k will be equal to this one. Determine the mean value of xt. So no new question. See, when you see a lot of question, okay, you will get everything. You will not find a new one. Now let's see this one. Consider the time series model defined by this. So that the autocorrelation with lag 1 for this process is this one. This is simple algebra, 8th class algebra. Okay. You need to find rho 1. So how can you find rho 1? You find Euler-Walker equations. Okay, after finding Euler-Walker equations, I can write this way. This is a general one. Okay, this is a general one. No alpha 2, alpha 1, alpha 3 are given. So if I write gamma 1 here, it will be alpha 1 or maybe let me try from this one. It will be alpha 1 gamma 2, alpha 2 gamma 1. Okay, then alpha 3 gamma naught. This is a AR3. It might bring a little bit complexity, that's a separate thing. If you write 2 here, alpha 1 gamma 1, alpha 2 gamma naught, alpha 3 gamma minus 1, that is gamma 1. Here 1 I have to write 0, alpha 2 minus 1, that is 1, alpha 3 minus 2, that is 2. So if you write 3 equations, because all you get in terms of 3 and you divide by gamma naught here, if you divide by gamma naught, you will get in terms of rows. Then you need to solve 3 equations. That's all. Nothing more than that. Okay. We are not using gamma naught here because you will get one extra term sigma square which is not appearing here. You need to solve these 3 equations, not the first 3, and you will be able to get row 1. It's not a problem. Okay. Simple algebra. Now considering that all are 0.2, alpha 1, alpha 2, alpha 3, all are 0.2. You need to comment on the stationarity of the process. They've given hint also, because this is a cubic equation. It took hundreds of years for the mathematicians to solve the cubic and biquadratic equation. You are not supposed to use the Cardan method of solution. They've given. Okay, so one root 1.278, it's greater than 1 in absolute value. The other 2 roots you can find from here, and you can check for stationarity. That's quite alright. And then you can find row 1, row 2 as well. Okay, row 1 is already there. You put alpha 1, alpha 2, alpha 3 here. Row 2 again you can find from these equations. Okay, you don't need to find the general form in this. That is not required. This is the last question. Yt is given. Okay, so now you need to decide what kind of process is this. Again, if you see this side, the characteristics polynomial will be 1.0.8 z is equal to 0. So there is no integrated part. Okay, so I can safely write arma here, because if you put z1, left hand side is not 0. There is no 0, there is no 1 root here. If you put 1 here, okay, you will get 0.2, not 0. So there is no d part here and 1 lag here, so I can write 1, and this side also 1 error, so 1. This is arma 1 1. Okay, so if you solve here, 1 divided by 0.8, 8 divided by 10, 10 divided by 8, okay, that is 5 divided by 4, greater than 1 in absolute value. So then what will happen? This is stationary. Invertibility you can check from this side if required. Here it's not required, so we will not check for that, because stationarity is important. Going forward, you see, we'll take the real world data, we'll write in the form of ARMA process, we'll forecast. Okay, invertibility has something, I'll go to that later maybe. Invertibility is not required when you apply and forecast. For uniqueness it's required. And MA process is always stationary. You will not worry about the right hand side. That is always stationary. Stationarity of the AR process is always in doubt. So that you need to check. And also if there is any I part, integrated part, that you need to remove. Sometimes we need to log transform also the series to make it stationary. There are certain things. We'll see all those things later. But this is ARMA 1-1 process. In the question you are supposed to find row K for K0, 1, 2. Okay. So again, to find row K, you have to form you have to form equations and you have to solve. Remember, these are not like Euler-Walker equations. When you find row K, they are not like Euler-Walker equations. Euler-Walker equations are for AR process, pure ARP process. We use Euler-Walker equations, and for pure MA process, I must have already explained you how to find the autocorrelations in one of the classes. Okay, they are different. Whatever way you find this, they are different. I never discuss for ARMA process how to find row K. Okay, how to find row K. I never discussed this one till now. Even that was a part of today's class. Maybe I will do next time. It's already late. Okay, next time it will take 10 minutes time. I will consider one important question, but this will be like this one. 80% you will feel like this one, little bit extra, okay, you need to do, and you will be able to find this one.